In this video, we are going to learn how to identify functions in tables, ordered pairs, and equations, and graphs. So let's begin. So let's start off by going over what is a function. A function is a rule that assigns each input with exactly one output. Functions occur when every x value is associated with exactly one y value. So, in tables and ordered pairs, now what is a table? Well, let me kind of show you on the side. A table is like one of these guys right here. So sometimes it's like x and y, and x refers to time, and y might refer to, like distance or something like that, distance in meters. Let's say at 0, the distance is 0. At 1 minute, the distance is 10 meters. And at 2 minutes, the distance is 20 meters. And at 3 minutes, the distance is like 25 meters or something like that. So this would be a table. Let's go ahead and do like 4. The distance is still 25. Ordered pairs, so that is a table. By the way, you can do this table in 2 different ways. You can have it, let's do another table actually while we're at it. Well, actually, let's do the ordered pairs because it's simpler. Ordered pairs, an example of ordered pairs would be, like for example, remember, ordered pairs are like the x value and the y value. So this first one would be like 0, 0. The next one, x is 1, y is 10. The third one, x is 2, y is 20. For the fourth point, x is 3 and y is 25. And for the fifth point, x is 4, y is 25 again. So those are ordered pairs. Ordered pairs. And you know ordered pairs probably most prominently from like graphing. You can also represent a table, like a horizontal table. So let me give you an example. Like you might have a table that looks like this, x and y. And the same points would be like 0, 0, 1, 10, 2 and 20, 3 and 25, so on. So again, if you wanted to turn this table into ordered pairs, it's still the same thing. If x is 0, y is also 0. If x is 1, then y is 10. If x is 2, then y is 20. So on and so forth. So these are tables, table, and ordered pairs. Now, in tables and ordered pairs, to test whether or not a table or a set of ordered pairs represents a function, looks to see if each input or x value has exactly one output or y value. Put simply, something is not a function, so you may want to write this down, not a function if x repeats. If you have a repeating x value. Now, you may have learned, for example, if you looked at different graphs and different word problems that related to graphs, if you have read stories, you may be familiar with how to like check whether a graph is a function or not. With a table, it's a little bit tricky. You interpret the story by looking at it this way. Let's say x is time and y is distance. Let's say at 0 minutes, the person is 0 minutes away from home. At 1 minute, the person is 10 meters away from home. At 2 minutes, he goes and he's 20 meters away from home. At 3 minutes, he goes a little slower because he's only 25 meters away from school. Let's say we continued our story. And at 4 minutes, let's say he's at 25 meters. What does this mean? Well, between 3 and 4 minutes, he hasn't gone anywhere. He's stayed put. So he's kind of going 10 meters and goes another 10 meters and then only goes 5 meters and then hasn't gone any meters between 3 and 4 minutes. And then at 5, he may need to walk backwards. He may need to walk back toward home, and so he may sprint home. And so at 5 minutes, he's at 10 meters. And at 6 minutes, he goes back home, so he's at 0 meters away from home. And at 7, he could be, you know, sprinting toward wherever he needs to go, so he could be 20 meters away from home. So this graph or this table can tell a story, or again, you could write it as ordered pairs as well. Now, this is a function. The story makes sense. What would make this not a function? Well, what if I had at 7 minutes, he's at 20 meters, but at 2 minutes again, he's at 12 meters. Why would this not be a function? Well, take a look. We have, what we said is if you have a repeating x value. So we have a 2 right here and a 2 right there. X is 2 over here and it's 2 over there. And according to this story, what I have, these points, it's saying that at 2 minutes, he was at 20 meters away from home, but at 2 minutes, he was also 12 meters away from home. Is that possible to be 20 meters and 12 meters away from home? No, it's not possible. It's like he's going back in time and going to 2 different places. Anyways, that's impossible. So if you have like a repeating x, and assuming the y values aren't the same, like this isn't 20 and this is 20, which would essentially kind of be a mistake. You shouldn't have the same point twice. But if you have a repeating x value in a table or an ordered pair, that would make it not a function. So not a function if x repeats. So let's take a look at number 1 and 2. So the only thing we're looking for are the x values. The y values are irrelevant. If y's repeat, it doesn't matter. If the x values repeat, it does matter. So let's look at the x's. It's we've got -2, -1, 0, 1, and 2. -1 and 1 are not the same thing, and -2 and 2 are not the same thing. So do we have repeating x values? We do not. And if we don't have repeating x values, that means, yes, this is a function. Why? Well, because x doesn't repeat. Doesn't repeat. The x's don't repeat. It's a function. Let's take a look at number 2. We're only concerned about the x values, which is the first value, -2, -3, -4, -2, and 0. Do I have repeating x values? I do. At -2, and we have -2, 1, and -2, 8. That means the x repeats, and it's not the same exact point. So is this a function? No. We have x values that repeat. It's not a function. No, x repeats. And where does it repeat? -2, 1, and -2, 8. So that's why 2 is not a function. 3, 4, and 5 are graphs. Now, how do we tell if a graph represents a function? Well, if a graph represents a function, it should be able to pass something called a vertical line test. This means that any vertical line drawn on the graph should intersect the graph at exactly 1 point. Remember, a vertical line is a line that goes straight up and down, not sideways, not diagonally, but straight up and down. So what the vertical line test is saying is that we've got this graph right here, this graph line. It's saying if I draw a vertical line, a line that goes straight up and down, if I'm able to draw a vertical line anywhere on this graph that touches this yellow highlighted line in 2 places, then it's not a function. So I don't think it's possible. Any line that I draw can only touch that, highlighted line in 1 place. So it passes a vertical line test. So that means yes, it's a function. Why is it a function? Lots of different explanations you could give, but let's just go ahead and say it passes the vertical line test. Passes a vertical line test. Does number 4 pass a vertical line test? Let's take a look at our graphed function or graphed line. Well, is there any way I can draw a line that'll touch more than 1 point on the line, a vertical line? Well, yes, I just drew a vertical line and it touches my graph line at 3 different places. So it did not pass a vertical line test. Why isn't this a function? We just say it fails the vertical line test. Vertical line test. All right, number 5. Let's take a look at our line, our graphed line. Will it pass a vertical line test? Can I draw a vertical line that touches this yellow line at more than 1 point? I cannot. Therefore, it passes a vertical line test. Yes. Why? Because it passes our vertical line test. Passes a vertical line test. Hooray. If we check the next page, now we are looking into equations. Is an equation a function resulting in a function? Something you need to keep in mind that is that equations, graphs, and tables are different ways to represent something. You can represent a story, a real-life situation, using equations or graphs or tables. So pretty much with, most equations, you should be able to graph them. And you should also be able to make a table out of them. And the same goes with tables. Any table of values they give you, you will be able to graph them. Any graph, you should be able to come up with some kind of equation to fit it. So tables, equations, and graphs. So they are all different ways of representing the same information. So if they gave you an equation, how can you tell if the equation creates a function or not, or is a function or not? Let's figure out. An equation represents a function if every input x will only result in one output y, or y. And they want you to substitute various input values to see if an equation represents a function. So if, gosh, I need to use a table for this one. And I can say, hey, if x is negative 2, let's go with negative 2. If x is negative 2, what's negative 2 square? Well, negative 2 times negative 2 is 4. So y, if this was negative 2 squared, what's that equal? That just equals 4. So y equals 4. If x was negative 1, so if x equaled negative 1, and I squared that, what would y equal? 1. Negative 1 squared is 1. So if x is negative 1, y would equal 1. If x is 0, what's 0 squared? It's also 0. If x is 1, y is 1. If x is 2 squared, that is 4. So we ask ourselves, do I have any repeating x values? Negative 2, negative 1. Is there any way I can get repeating x values? No. And in fact, if I graphed this, you can see that you'd end up with a graph that passes a vertical line test. It would end up looking like, basically ends up looking like a U. We call this a parabola. And would this graph pass the vertical line test? It would. So we are going to say yes, this is a function. Now, for number 7, if I was to do a table for number 7, table of values, x and y, this is the confusing part. If x is 1, what can y be? Well, let's see, y squared equals 1. What numbers would, what can y equal? Well, y could equal 1, because 1 times 1 equals 1, but can't y also equal negative 1? So negative 1 times negative 1 also equals 1. So it's almost like if x is 1, y can actually be 1 or negative 1. Which, doesn't that mean it's not a function? Because I would end up having 2 points at, that's point 1, 1, and also point 1, negative 1, which is confusing. Here's the thing. If I graph this, the graph ends up looking like this. And definitely this graph would fail a vertical line test pretty much everywhere except for one place. So this is not a function. No, not a function. And you may be wondering if number 8 is a function or not. Well, I'm just going to tell you straight up, it is not a function. Now, rather than like graphing everything out, is there an easier way to determine whether an equation is a function? Well, let's see. Can you figure out what this equation and this equation have in common? How is it different from this one? Now, you may have figured it out. You may have noticed, wait a minute, this has a y square, and this has a y square, and this right here has just a regular y. If that's the thing you pointed out, then you are correct. If you have a y square, it's not a function. So I'm going to go back up here. I'm going to say, give you another rule. Not a function. Not function. If y is raised specifically to the second or any even number power. So if y is raised to the second power or any even number power, example, y squared, y to the fourth power, y to the sixth power, y to the eighth power, so on. So if you have y to the third, technically that's still a function. Y to the fifth is still a function. Y to the seventh is still a function. You know, if you graphed any of these equations that has y squared or y to the fourth or y to the sixth, you would end up with something that is not a function. So if you want to explain why is number 6 a function, well, it's because y is to the first power. Or you could say y isn't squared or isn't raised to an even number power. Y isn't raised. Or, you know what, y is in the first power. In the first power. Or you could say it's not squared. Why is number 7 not a function? Because BC y squared. Why is number 8 not a function? Because y squared. That's it. All right, let's try some examples. Determine if the following are functions by labeling yes or no and justifying our answer. Well, when we have ordered pairs or a table, our rule is if you have a repeating x, it's not a function. So do we have any repeating x's? We do not. So as far as we know, it's a function. So yes, it is a function. X does not repeat. Does not is DN, does not repeat. Number 10. Again, same rule applies for a table. Do we have any repeating x's? -7, -5. Oh, we do. We have this repeating -7. So that means it is not a function. No, because x repeats. And then we should give which points it repeats at, -7, 1, and -7, -1. Number 11. Different set of rules. What is our rule? We check to see if y is raised to the second power or an even numbered power. So we don't really care about anything else. We only care about the y. Is y raised to the second power? It is not. That means this is a function. Yes, y is to the first power, or you could say y isn't squared. Isn't raised to even numbered power. Or you could even say y is just raised to the first power. Number 12, is this a function? Here's the thing. Here's our graph. Does it pass a vertical line test? Yes, it does. So yes, it is a function. Y passes a vertical line test. Vertical line test. Number 13. Again, a couple of ordered pairs, so we're looking at the x's. We have 9, 0, 4, and 9. Let's make sure we have 9, -15, and 9, 2. That's definitely not the same point. So if we have a repeating x, it is not a function. No, x repeats. And it repeats at 9, -15, and 9, 2. And number 14, what is our rule? Well, we're looking for a y raised to an even number power, and it is. So that means this is not a function because BC y is squared. And that's it. That is how you determine whether something is a function using a table, ordered pairs, graphs, and equations. Remember the special rules. For tables and ordered pairs, you're looking for repeating x's. For graphs, you're looking for passing the vertical line test. And for equations, you are looking at the y and seeing if it's raised to the second power or any even numbered power. Go ahead and try to answer some questions on your own. Good luck.